Hello everyone, welcome to Introduction to Machine Learning for Data Science Beginners course. We are going to learn first what is machine learning and what are the types of a machine learning. Machine learning evolved from a computer science that primarily studies the design of algorithms that can learn from experience. To learn, they need data that has a certain attributes based on which the algorithm try to find out some meaningful predictive patterns from the input data. And then finally, it generates a target output. The classification of machine learning is generally a four type. They are supervised machine learning, unsupervised learning, reinforcement learning, and semi-supervised learning. In a supervised learning, we have input data and output label or a target label. In a supervised learning, we do not have an output or a target label, we have only input data. In reinforcement learning is a kind of learning which is a continuous learning in a real environment. In a semi-supervised learning, we have a kind of output data and as well as input data for the prediction. Categorization on the basis of required output, we can classify machine learning algorithms in three types: classification, regression, and clustering. In classification, we have a certain type of output or a finite number of outputs. In regression, we have a continuous type of the outputs. And in the clustering, we do not have any special type of the output. I mean to say, in the clustering, in general, it produces the finite amount of target output, but we do not know how many output it is going to produce in the clustering. But in the classification, we know before training the algorithm that there are a finite number of classes in the output, but in the clustering, we get after the training our algorithm. And this clustering is unsupervised learning. There are many tools available for machine learning algorithms like scikitlearn, TensorFlow, Keras, Ktrain, and the PyTorch. So we'll be using kind of all of these libraries or Python packages in our course, and we will be utilizing these things very beautifully in this course. These are some of the famous algorithms, although there are many more type of the algorithms, but in general, these are the famous algorithms for the beginners to get started with the machine learning. I have another course on advanced machine learning, and that is specialized in advanced NLP course, and there I have described a little advanced algorithms in machine learning, and I have also described how you can deploy your machine learning algorithms on the internet. You can go to my profile and then you can enroll in that course. The basic type of the algorithms are regression, logistic regression, SVM, decision tree, and the random forest. A regression is a regression type of the algorithm where we have a continuous type of the output. A logistic regression, SVM, decision tree, and the random forest, although these can be also used as a regressor. So mostly we will be learning about these four type of the algorithms at the first, and then we will be also learning CNN, RNN, and LSTM GRU transformer later in this course. There are many type of the clustering algorithms such as the k-mean clustering, k-shift clustering, density-based spatial clustering of applications with the noise, expectation maximizations clustering using Gaussian mixture models. So these algorithms we will be also discussing later part of this course. These are the model training, and this is the schema how in general we train our model. Let's say we do not have a data, so the first of all we need to collect the data. Thereafter we clean the data, alright, and then we build our model. Thereafter we train it and then we validate it, and then we test it. If there is any error, then again we train it, validate it, and test it. Once model is finalized, and suppose that at this place you have got your final trained model, then at the stage of the deployment, Then we can also do directly feed this data which is coming from data cleaning directly into the model testing, and then we can again test our model. Alright, and thereafter once this testing is done, then we can deploy our model. And if you see it at the abstract level and at the stage of the deployment, it is kind of, let's say you have here level data and training code. So this is kind of the data which you want to train. Then you build the model. Once model is built, then you write an application code for your model deployment which runs at the server. Thereafter, once it is deployed in the production, then you call this model prediction using HTTPS request, API requests, and then finally you receive the data or predicted data. Alright, so during the training, we actually divide our data in two sets. It's a training set and test set. Sometimes we also divide this data in a three set: training set, validation set, and test set, as we have already seen it in a previous slide. So the training set is a subset of the data which we use to train the model, and test set is the subset of whole data which we use to test the model. And similarly, if we talk about the validation, we can say that the validation is a set of the data or a subset of the data which we in general use to validate our model. Alright, perfect. So the one more thing you need to pay attention here is that, let's say once you have splitted your data in training set and test set, you should also make sure that your test set meets the following two conditions. Your test set should be large enough to yield statistically meaningful results. Alright, that mean it's like that. It's not like that. I split your data in just 2 or 3 instances of the testing set. Split your data in at least 10 to 20% of the data so that you can actually test your data in a larger variety, of your data. Then the second step is representative of the data set as a whole. That's mean whenever you get this test set, alright, so in this test set, you should have all the type of the data as most as you can try. It means that, let's say, if you have the two classes, class 1 and the class 0, and if you put all the data of class 1 in the test set, then you are not going to good accuracy. In fact, even though if you get the good accuracy, but that doesn't mean that your model is robust, because you have just placed a single type of the labeled data in the test set. So you should try to put a balanced type of, that's mean it should include all the type of the data in the test set. In other words, you can say here, don't pick a test set with different characteristics than the training set. Alright, perfect. So this is all about in this lesson. Thanks a lot for watching it. I'll see you next lesson.